Good morning, everybody. Today's date is Monday, May 25th. Happy Memorial Day to everyone in the United States, and greetings to everyone around the world as we just take a moment here to remember all those who we've lost through this terrible pandemic. I just want to make sure they're remembered on this Memorial Day because they were fighting their own war, a very hard one at that. So I'm Tom Kaczynski. Welcome to episode 74 of Coronavirus Central. All previous episodes up at coronaviruscentral.net. The Telegram group is t.me/coronaviruscentral. And I want to thank everyone who's been helping me in my effort to get my computer fixed. It's in the shop now. I'm just waiting to find out how bad the cost is going to be. So all help appreciated very much. P.O. Box 35, Greenville Junction, Maine, 04442, as well as the Venmo CVC PRV. And I want to thank people for their generosity. Wednesday being the 75th show, a little bit of a special silver anniversary, I guess you'd say. We are going to acknowledge all of the people who have been so helpful, and a very different sort of show for you, actually. A lot of you have asked me for a long time to do a show focused on preparedness and what I am preparing for and what I recommend families prepare for the days ahead in this uncertain pandemic. And I think we're at a good time to have that show. So we will do that on Wednesday. And then on Friday, we'll talk about a combination of politics, economics, and any breaking news that happens over the week. I think we're a little bit in silly season right now, and even though I'm not covering it, I very easily could show you story after story of a bunch of people going out and partying, and these are going to be the hard times of this battle. This is going to be there was a time in World War II where they called it the False War, after Germany had invaded Poland, but before they invaded France, where they just kind of sat at both sides, neither really shooting or saying something, while there were thoughts that a peace treaty might happen for 6 months, until the Germans did an end around through Belgium, through the Ardennes forest, and then 6 weeks later, Paris was flying the swastika. So we are now in that time within this virus. We are in the time in between where the virus is in the laboratory, that is us cooking something up for us, and people are ignoring it. And I know that it's going to be a hard time, and I've had a lot of you say, hey, how do I hold on? How do I keep believing in this? And what I tell you is the same thing that I say every show. The purpose of Coronavirus Central is to keep you safe and to let you know there are risks out there. Do we know that it's going to be terrible? God, I hope not. And do we know that we're going to have a bad mutation or that things won't get better? No, we don't know that. But we know the risks are real. We know that the damage has happened. We know that we have millions of people who have been injured by this, hundreds of thousands who have died, numbers growing all the time, and we continue to learn new things about this evolving, changing virus. And in that sort of environment, I submit to you is that the smart play, whether it's the popular play or not, is to keep safe. And now it's going to be a different game for a lot of us because there's going to be a lot of peer pressure from workers, from employers, from family members even, about what the right move is and whether or not it's justified in trying to keep safe anymore. And I believe it is. I absolutely believe it is. History argues that. The virology argues that. Anyone who's taking this seriously, from the U.S. military onto the scientists who are writing these term papers, a lot of people think that, research papers, I should say, think that we're going to be dealing with a second wave. And a lot of people just don't care because they assume they're invulnerable and they may be contemplating an absolutely terrible risk. When we first saw this thing launch out of Wuhan, a lot of us thought this was going to be the big game changer where you could have a significant proportion of humanity be permanently impacted. We have been fortunate to this point that hasn't happened, but I would submit to you, not only does that possibility remain out there, but given all the geopolitical happenings happening at the same time, given our understanding that there's artificiality at the heart of this virus, given the state actors who could basically get away with genocide at this point and have plausible political cover, and all of these factors out there, the world has become incredibly unsafe, and that we have to be very wise about choosing to move forward in this world in a way that protects ourselves versus acting foolishly. And that is my message to you. I live my own message. I believe in it. And whatever friends you lose, whatever politics you upset, whatever people don't understand you, ultimately your obligation is to yourself and to your family, and then from there to your community. If your community is going to behave awful, I think of our listeners. I have some down in Texas and Georgia and Tennessee who write me regularly. Great people who are stuck in a dangerous situation where their own people don't really value health and life that much, and where their governments are determined to ignore these things. Recognize that you can be different. Do not force yourself to be what others are. If you have to go out there, protect your eyes, protect your mouth, do what you have to do. Be smart about it. It's like even here in Maine, I saw a bunch of people up here this weekend. Everyone's running around splashing hand sanitizer, thinking it's going to save them, not even recognizing that an antibacterial ain't going to do crap against a virus. But that's the way it is, and that's the way it always is with these sorts of things, that people aren't going to be aware, and the reality is intelligence is a regressive trait. So if you're fortunate enough to possess it, which I assume you do by the fact you're listening to this show, go ahead and use it to your advantage, use it to your family's advantage, and use this time and in this reopening, this grace period, to collect the things you need and want. And we'll talk about that in much more detail tomorrow. I'll go through my own thoughts on preparedness, within a pretty limited budget. In fact, I will assume for the purposes of this that your budget, when we talk about it tomorrow, will be the equivalent of an unemployment check plus the support from the government, where at least half your money has to go to rent and other bills and expenses. So that we're looking at it from a very realistic, expensive, what are some cheap things you can do that would give you an edge, and what would we do from there. So for today's stories, what we're going to do is we're going to do kind of a classic coronavirus central type episode. We're going to look at a little bit of news and a lot of medicine, and I like to do that on Mondays, usually around the weekend, just as we go into there, all the big reports drop. And I literally read about 10-15 medRxiv and bioRxiv preprints this morning. I have one that I think is really important. We're going to go through. I have 3 or 4 I'm going to mention. I'm just going to read you the headline of it and make a couple comments. I don't think it warrants a full show coverage of some of these, but I think there's some interesting stuff in there about pets for transmission, about other animals transmitting potentially that are out there, and just stuff they're discovering about the virus. A lot of different medicines being looked at that have different efficacy. But what concerns me more, and where I'm going to try to start the story today, is by looking at how this virus is evolving, where it's evolving. And, when you're looking to put out a fire, you look where smoke is. So we're going to start today with a brief glimpse into Brazil and the developing world, where the virus is really taking root in a very hard way. And, part of that obviously is going to be problems in the medical system. However, remember, COVID is, I should say SARS-2 rather, the virus is a recombinant RNA virus, and we have seen that it has the potential to grab other bits and pieces going forward, and I worry about what happens when when this virus spreads into other places. And let's say it combines with something from a coronavirus in a South American bat, and it grabs a useful adaptation that's positively selected for. What happens then? And that's something a lot of people are worried about, and they should be. So let's take a quick look here. I'm just going to read to you the top line numbers before we go into all the stories. And this is going to be from COVID-19info.live. It's 7:10 a.m. on May 25th. It's actually 7:32, but I don't want to script this thing. We are looking at confirmed 5.5 million cases, were 347,381 deaths, and 2,326,998 recoveries. Just looking at the case numbers, the United States here, we're at according to this, 1,686,436 confirmed cases, 99,300 deaths. That means that'll go over 100,000 today. I believed we already were, but if we're not, we will be by the end of the day. Brazil is now up to number 2, and they're at 365,213 cases. At 17,815 gained, they're at 733 new deaths, up to 22,746. And I think this is really interesting because Russia By comparison, is the third country at 353,427, only 3,633 deaths reported, 245. And while there is a difference in population there a little bit, the fact that we're having such different disease profiles really makes me wonder, are we dealing with something fundamentally different in Brazil? And as I'm looking at other countries coming onto this first page, Peru, Chile, Mexico, I'm looking at lots of Latin America, and I know Ecuador's gotten pounded, even though they're not on the first page, just on raw numbers. Something I'm very concerned about. So just quick countries of interest note. UK, 261,347 cases, 36,931 deaths. Canada, 86,105 cases, 6,533 deaths. And let's see if there's anything scary on the second page that I want to mention moving forward up the list. Yeah, no, I think that's pretty good. Okay, so let's go into, and that's from COVID19info.live here. We're going to do a couple quick hit, small pieces just about things happening around the world, things I'm kind of keeping an eye on because I'm wondering what relevance they may have. Might have some, might have none. It's hard to say. At this point, everything on coronavirus reporting on the mainstream media is so politicized that it's really difficult to find good information. And I will tell you, at this point, I'm literally investing as much of my energy into wondering and worrying about a war with China and the new Cold War developing. One thing that's interesting out there, if you want to take a look just as a follow-up to the Dragon and the Eagle episode, is China developing stronger fortifications on land that India has also claimed. So if you're looking for a second front, keep an eye on that. That's going to be a big part of this, especially as global supply chains move around. India's wanted a bigger share of that for a long time, and they seem to have thrown in with the West, which actually is quite different than what happened in the 70s between Nixon and Kissinger, where basically India went non-aligned and the Chinese were separated from the Soviet leadership in Russia, which was considered the greater geostrategic threat at the time. Okay, so we'll keep a very close eye on that, and I will tell you, people ask me all the time, what's the one thing I'm most worried about beyond the virus? And I say without any hesitation, the fact that we may be stumbling into a world war, and we'll talk a lot more about that in days going forward. It's a big part of this story, and how we play with the virus actually is at the heart of it. Okay, so this piece we're going to start with, this is by Bloomberg, and the author's name is Mario Sergio Lima, May 23rd, 2020. He published this at 7:49 Eastern Time. Brazil coronavirus curve steepens after overtaking Russia. And I should let you know, last week I managed to figure a way to work around it. This week I'm not going to be able to list the articles beyond what I share in the show, so you're going to want to take notes if you want to look things up. Hopefully, as soon as I get the computer back, this will be a lot easier. You have no idea how much harder this is for me, but I'm going to try to keep going. And we'll see if it loads today, because I had to do it a different way last week. And if I have to keep coming up with new ways, I don't know how well this is going to work. But if you're hearing it, obviously I figured it out. If not, I'll have it up on YouTube. That's a lot easier. All right. Brazil's coronavirus curve steepened further a day after it overtook Russia to become the country with the second highest number of cases. The Latin American nation added 16,508 cases Saturday and said the death toll rose by 965. Brazil now has 347,398 confirmed cases, trailing only the United States globally from 330,890 on Friday. Still, its death toll of 22,013, up from 21,048 in the previous 24 hours, trails the United States and some of the most infected European countries, including the UK and Spain. As the country shattered records and the contamination curve fails to flatten, President Jair Bolsonaro remains adamant about his crusade to reopen commerce and the economy and to tout the malaria and lupus drug chloroquine, even though there isn't sufficient proof to back it up for COVID. His stance, and that's, I don't really agree with that. I mean, chloroquine works. It doesn't solve every problem. It's an early thing you can use to limit damage to your blood. It doesn't cure COVID, but it is helpful. And a lot of the tests, I should say, because I've looked at them since everyone wants to talk about, here's my quick take on hydroxychloroquine from a guy who was talking about this in February. It helps. It's not a magic solution to everything. It's useful. It's better when you do it with azith or zinc. And that if you do it early, if you give it to someone when it's already late, it's too late to make a difference. It's not going to do you any good to block off access to a red blood cell that's already been infected. And a lot of the studies that are out there are sort of disingenuous about that. But like anything else, if you create one common treatment, you're creating, actually, let me say it more accurately, you're creating a selection pressure for the virus to evolve in a different direction. And we may be seeing that. And that's one of the reasons why we're going to talk a lot about Brazil in the coming months. Because if the virus is going to change, that's one place that's very likely to keep an eye on, as are other places in the developing world, such as potentially India. Okay. His stance has proved too much. 2 health ministers have resigned amid the pandemic. The ministry is currently being provisionally run by an army general. And I will say this about Bolsonaro. Bolsonaro seems basically to not want to believe in this and to want to keep it open. This guy got elected basically to try to fix the economy, and that's pretty much all he cares about. And Brazil being Brazil, it's not like, even though they're a democracy, it really is a question of certain interests being well taken care of, including the military, which seems happy with Bolsonaro, and you may see a coup there in favor of the president against the governors. We'll see. It's a mess down there, and I can't pretend I know every bit of that situation. Earlier on Saturday, Nelson Teach, who resigned last week as health minister after 29 days on the job, refused an invitation to act as counselor for his replacement. In a Twitter post, Teach said it wouldn't be coherent to accept that 1 week after leaving the job. So, as you can see, the elected leadership there just keeps cycling through the medical personnel. And Bolsonaro is just, it's not going to end well for him. We all know that at this point. And that's what happens when you have a wrong priority in your country. I don't know how else to put it. It's very sad what's happening for the people in Brazil. And I pray for them because it's going to get a lot worse before it gets better. But as you see a whole bunch of people out there partying, wherever you are, anywhere from Maryland to Texas, from Maine to Washington, people are going out and having a good time before this was handled. And, it's kind of like what we saw in 2003. George W. Bush gets on an aircraft carrier, or 2005, George W. Bush gets on the aircraft carrier, puts up a big sign that says mission accomplished, celebrating victory. And we were still in the Middle East, here we are 15 years later. So the point is, you probably shouldn't be celebrating victory until you've won something, and we haven't won anything against this virus. In fact, the virus is winning against us, and the fact that things slow down for a little bit is going to totally go the other direction, and now we're going to see something that's going to be far worse. There's no doubt of that. You have a lot of studies floating around out there saying people don't have antibodies very long. They're not very strong when they are. A lot more people interacting, and social distancing, which was always an arbitrary number, by the way, on the short side of it, has become a joke. We have people going around wearing cloth masks, which is better than nothing, but honestly aren't really going to protect you. Their eyes are uncovered. There's masses of humanity. Everyone's moving around. Everyone's having a good time. And now we're at it. And look, people say, oh, what do you want to do? Stop everyone from doing it? I'm like, I know that's not going to happen either, because people have economic needs and that those were deliberately not met. My message now becomes very simple. I'm not trying to tell you how to save everybody. I don't know how to do that, and ultimately we're not going to do that. My job is to warn those who care to listen about the things and dangers coming forward and what you can do to keep safe, and that's all we can do at this point. So big solutions, I don't have them. If they get 50 or 100 families, build a fortress, and decide we're not going to let anyone in who has this, I think that's actually the best solution I can come up with at this point, because this is what happens when you have a group of people whose priorities are in the wrong place, and that's what we've seen, and that's been the problem. And then, people start getting hurt, because right now, everyone thinks it's not too big of a problem, because they're like, oh, it's just old people, or sick people, or people who have diabetes or something. But the virus will evolve, and it will find ways to reach new populations, and bad things may happen. To wit, this piece by Ellen Cranley, published 17 hours ago in Business Insider. This may be a hint of what the future has for us. Coronavirus is reportedly killing young people at unprecedented rates in developing countries. And they show a picture here from the Via Formosa Cemetery, where dead bodies of the coronavirus pandemic victims are buried in Sao Paulo, Brazil, on May 22nd. Younger people in developing countries have been dying at unprecedented rates from the novel coronavirus, according to the Washington Post. The Post reported that people under 50 made up 5% of the deaths, and nearly half of the dead in India were younger than the age of 60. The new analysis comes as Latin America and India emerge as hotspots of the coronavirus pandemic. Data from the developing world and initial demographic indicators from the U.S. highlight the grim effect socioeconomic factors have on who is more likely to be infected or killed by the virus. Now, they are assuming, I will say in this piece, and the Washington Post was assuming it as well, and I know why they assume it. They're assuming that the reason why this is happening is because of socioeconomic conditions, which is to say, if you live in a third world country, it's harder to get along. I don't take anything away from that. I think that's likely true. However, I think that we need to keep a close eye, because if a mutation's going to come, what are these countries? Warm weather countries, near tropical environments, reservoirs of things that have a lot of weird viruses to begin with. So if we're looking at places like West Africa, Latin America, South Asia, Southeast Asia, if there's going to be mutations coming forward, these are areas we got to keep a close eye on, especially as we're in the hot season and things are going to be spreading into some of these viral reservoirs. That's one of the things actually I was reading about in a study I'll mention later. It's talking about which animals are most likely to carry this beyond bats and pangolins, and there were some interesting things in there. Ferrets were in there, minks were in there, leopards were in there, deer might potentially be in there, and they did a predictive study on it. It's really kind of hard to read. I'm going to mention it so you have a chance to take a look at it because it's highly technical, but they predict that while house pets probably aren't going to be too big of a problem, a lot of wild things kind of on the rodenty side could be carriers of this. We'll have to keep an eye on that, as well as things that are more maybe to like a deer, goat, some of those areas. Not likely, but not impossible, especially if mutations happen. So we'll look at that too. So, younger people are dying at unprecedented rates from COVID, the disease caused by the novel coronavirus, as developing countries become new hotspots for the pandemic, the Washington Post reported. As the coronavirus has been ravaging countries in the developing world like Brazil and India, young people make up a population of the victims and hospitalized patients at a rate unseen in previous epicenters, according to the report. In Brazil, people under the age of 50 account for 5% of deaths, 10 times that greater recorded in Italy or Spain, the Post reported. And in Mexico, nearly one-fourth of the dead were aged between 25 and 49. In India, another rising hotspot, officials reported this month that nearly half the dead were younger than 60, according to the Post. The same trends can be seen in hospitalizations with patients for patients with extreme cases, the Post reported, like in Brazil's Rio de Janeiro state, where more than two-thirds of the hospitalizations are for people under the age of 49. And what does that mean? Maybe it means we're seeing something different come forward here in terms of what the virus is doing. And we'll talk about why I think that. The Post wrote that experts point to existing issues like overwhelmed healthcare, extreme poverty, and inequality as exacerbating factors in the death tolls recorded in developing countries. In India, the explosion of cases in Mumbai has been connected to the dense cityscape and conditions in areas like Dharavi, Asia's largest slum, where hospitals are overwhelmed, police forces overextended, and social distancing is impossible, the New York Times reported. Though authorities announced in the initial weeks of the pandemic that older individuals were most at risk from death from the novel coronavirus, the past few months have provided widespread evidence that serious cases are likely to strike younger people between 20 and 44, and analysis like the Post highlights the grim effect socioeconomic factors can have on who is more likely to dodge or survive the virus. In the U.S., officials have identified sharply higher rates of coronavirus infections and death among non-white Americans in preliminary data that have been connected to higher rates of comorbid diseases and other issues like limited access to health care. I think we also saw that it has an issue with that B-cell expression. We'll have to keep an eye on that too. After initial numbers from states like Michigan, Illinois, and North Carolina reported last month showed African Americans were by far the hardest hit by the coronavirus, experts clarified that the pandemic did not run through all communities equally. A recent study by AMFAR, in coordination with a team of epidemiologists and clinicians from 4 U.S. universities, reported by CNN, concluded that a wide array of structural factors, including healthcare access, density of households, unemployment, pervasive discrimination, and others derive these disparities, not intrinsic characteristics of black communities or individual level factors. I don't know if that's fully true, to be honest with you. I know that that's a political statement because of who said it and how they said it. And I don't disagree that there is certainly healthcare inequalities, but I think there might be something in the genetic expression there. And the reason why I say it is we saw the evidence of it, and it's not anything anyone can help. You just have that B-cell issue that's out there. And that's one of the things that actually, there's a study I'm going to mention today, we're not going to go into it. It looks at trying to create immunotypes so you can predict who's going to have problems based on genetic expression. And because so much of the story of when you get really severe COVID is caught up in the question of, do you have the appropriate immune response? Because if you have one that's too little or too late or too early, all of these things seem to cause major problems. And that is at the heart of this story, and probably goes back to that CD147 receptor that we are seeing is so critical to this, that COVID is causing dysregulation of the immune system. And in the cases that are most severe, that is what's happening. And if you can, that's why things like chloroquine, just one example, can be useful in the beginning, because they will prevent you from being so overwhelmed and having such a huge response that you are in major trouble. Okay, so the next piece I'm going to come forward with for you, this is from Stat News. It was from May 21st, so a couple days ago. Sharon Begley wrote this. It's something I've never seen, how the COVID-19 virus hijacks cells. And I wanted to read this for you so that you have an opportunity to have a better understanding of what the disease is doing. One of the things I feel real strongly about with this program is that I want our listeners to have the ability to understand what it is the virus is doing, how it operates, and how it works upon you. Because, you are very capable of understanding the basic principles by which COVID is attacking you. And then you can make intelligent decisions about how you think you want to respond to those threats, both in terms of safety and what terms of risk exposure would be most appropriate for you in your specific situation. Okay, so the piece, like I said, is by Sharon Begley. A deep dive into how the new coronavirus infects cells has found that it orchestrates a hostile takeover of their genes, unlike any other known viruses do, producing what one scientist calls unique and aberrant changes. And I just sort of wonder, I like this piece because it really shows you just how different it is, and it's so different from anything else you see in nature. I guess it gives us one more opportunity to ask that question is it natural? And we're going to talk about the PRRA insert as well. We're going to do a deep dive into one study because I think it might be really important. Recent studies show that in seizing control of the genes in the human cells it invades, the virus changes how segments of DNA are read, doing so in a way that might explain why the elderly are more likely to die of COVID, and why antiviral drugs might not only save sick patients' lives, but also prevent severe disease if taken before infection. It's something I've never seen in my 20 years of studying viruses, said virologist Benjamin Ten Over of the Icahn School of Medicine at Mount Sinai, referring to how SARS-2, the virus that causes COVID, hijacks cell genomes. The something he and his colleagues saw is how SARS-2 blocks one virus-fighting set of genes, but it allows another set to launch, a pattern never seen with other viruses. Influenza and original SARS in the early 2000s, for instance, interfere with both arms of the body's immune response, what Ten Over dubs the call to arms genes and the call for reinforcement genes. The first group of genes produces interferons. These proteins, which infected cells released, are biological semaphores, signaling to neighboring cells to activate some 500 of their own genes that will slow down the virus's ability to make millions of copies of itself if it invades them. This lasts for 7 to 10 days, Ten Over said, controlling virus replication and thereby buying time for the second group of genes to act. The second group of genes produce their own secreted proteins called chemokines that emit a biological come here alarm. When the far-flung antibody-making B cells and virus T cells sense the alarm, they race to its source. If all goes well, the first set of genes holds the virus at bay long enough for the lethal professional killers to arrive and start eradicating virus. Most other viruses interfere with some aspect of both the call to arms and the call for reinforcements, Ten Over said. And if they didn't, no one would ever get a viral illness. The 1-2 punch would pummel any incipient infection into submission. SARS-2 uniquely, however, blocks one cellular defense but activates the other. He and his colleagues reported in a study published last week in Cell. They studied healthy human lung cells growing in lab dishes, ferrets, which the virus infects easily, and lung cells from COVID patients. In all three, they found that within 3 days of infection, the virus induces the cells call for reinforcement genes to produce cytokines, but it blocks their called arms genes, the interferons that dampen the virus's replication. So this is actually a really great description of what happens. Basically, what they're doing is that they have the virus attacking you at the same time your immune system's attacking you, because everything's out there fighting a war, and what ends up happening is the body ends up having collateral damage because the interferons aren't there to stop things. They are not the reinforcements are there. Only the fighters are there, not the defenders. The result is essentially no breaks in the virus's replication, but a storm of inflammatory molecules in the lungs, which was what Tenover calls a unique and aberrant consequence of how SARS-2 manipulates the genome of its target. In another new study, scientists in Japan last week identified how SARS-2 accomplishes that genetic manipulation. Its ORF3b gene produces a protein called a transcription factor that has strong anti-interferon activity. And in fact, we're going to go into this a little bit. ORF3 is not something we have been, and that's just open reading frame. That's a part of the protein involved with the development of the virus. But we're going to look at that because specifically. There's another study that just came out about that, saying that mutation is co-apparent, comes forward with the D614G that we've talked about. So these two are very much linked. So at the same time that we have the ability to spread greater amounts of virus, because that's what that clade is doing, it's allowing a better bonding at the motif site, that we also have this strong anti-interferon gene that is serving to restrict the immune response in a way that's quite harmful to the body, because you end up with cytokine storms. Anyway, the protein basically blocks the cell from recognizing a virus is present in a way that prevents the interferon genes from being expressed. In fact, the ICANN school team found no interferons within the lung cells of COVID patients. Without interferons, Tenover said, there's nothing to stop the virus from replicating and festering in the lungs forever. So think about this. Even if your body can attack this, it doesn't mean it's going to go away. He's saying that the virus has the ability to stop the interferons. Without the interferons, it's just going to keep replicating. That causes lung cells to emit even more call for reinforcement genes, summoning more and more immune cells. Now, the lungs have macrophages and neutrophils and other immune cells everywhere, Tenover said, causing such runaway inflammation that you start having inflammation induce more inflammation. At the same time, unchecked viral replication kills lung cells involved in oxygen exchange, and suddenly you're in the hospital in severe respiratory distress, he said. So basically, it's interesting, right? You basically have all the killers there and no one there to go ahead and stop the battle. It just gets worse and worse and worse, and that's one of the problems if the interferons get stopped, and that seems to be at the heart of this issue of this, what I would argue we're learning more and more each day in its severe form, is functionally proving to be an immune disorder. In elderly people, as well as those with diabetes, heart disease, and other underlying conditions, the call to arms part of the immune system is weaker than in younger, healthier people, even before the coronavirus arrives. That reduces even further the cell's ability to knock down virus replication with interferons and imbalances the immune system toward the dangerous inflammatory response. The discovery that SARS-2 strongly suppresses infected cells' productions of interferons has raised an intriguing possibility that taking interferons might prevent severe COVID or even prevent it in the first place, said Vineet Minachere of the University of Texas Medical Branch. In a study of human cells growing in lab dishes described in a preprint, he and his colleagues also found that SARS-2 prevents the vast amount of interferon genes from turning on. But when cells growing in lab dishes receive the interferon IFN1 before exposure to the coronavirus, the virus has a difficult time replicating. After a few days, the amount of virus that was infected in interferon-treated cells was 1,000 to 10,000-fold lower than the infected cells not pre-treated with interferon. The original SARS virus, in contrast, is insensitive to interferons. So maybe there's something there that could be really useful. Maybe that you could have interferons that would be helpful, although the problem is, could this evolve to get around that? But I mean, you're looking for a solution, and it's an interesting thought. Ending the pandemic and preventing its return is assumed to require an effective vaccine to prevent infection and antiviral drugs such as remdesivir to treat the very sick. But the genetic studies suggest a third strategy, preventative drugs. It's possible that treatment with the so-called type 1 interferon could stop the virus before it could get established, Menachery says. Giving drugs to healthy people is always a dicey proposition, since all drugs have side effects, something considered less acceptable than when a drug is used to create an illness. Interferon treatment is rife with complications, Menachery warns. The various interferons, which are prescribed for hepatitis, cancers, and many other diseases, can cause flu-like symptoms. But the risk-benefit equation might shift both for individuals or for society if interferons or antivirals or other medications are shown to reduce the risk of developing serious COVID or even make any infection nearly asymptomatic. Interferon would be warning the cells the virus is coming, Menachery said, so such pre-treatment might allow pre-treated cells to fend off the virus better and limit its spread. Determining that will, of course, require clinical trials, which are underway. The danger, just so you understand, the really big danger with preventative treatment is when you go ahead and you build a defense in your body for one specific thing, that your body tends to overlook other things. So you might have a really bad flu season, let's say, and that the interaction between different plagues, diseases going around is complex and highly unpredictable. And when you begin premedicating, you're basically prejudicing your body in ways that can prove potentially harmful with other things going on out there. So we'll see what's out there. I think it's a good piece, though, and it's an interesting piece to keep an eye on as we go forward this question of how we're going to work with these interferons. So we'll take a look at that to be certain. So we're going to do a lab study now, and this piece is by a team that worked together. It's on bioRxiv, so biorxiv.org. An insertion unique to SARS-2 exhibits super antigenic character strengthened by recent mutations. And by super antigenic, what we really mean is if an antigen is a virus, then that means that the super antigenic character is that there's immune response that is beyond what is required, which is superlative, beyond what is required by the virus. And that's what's causing people to get really sick in at least some instances. That's pretty well understood. And it talks about this insertion being caused uniquely because of the PRRA insert that we've talked about certain times. So this is, it's sort of a technical piece. I have gone back and forth about how much detail I want to go into on this, but I'm going to read it all, I think, mainly because we might skip some of the results section just because it's going to be very, very difficult for me to read in a way but I will read the key lines from it. I will read also the introduction, the significance of this, which I don't usually do, and we'll read the results as well. But what they found in this study was that what was beginning to happen with some of these weird things, including potentially that Kawasaki disease symptom, was actually something that would fit well in an antigenic autoimmune sort of problem. So let's just go into it. I've read it once in passing, but we'll read it a second time. It's worth reading, and you know, this should be a big hint of where the problems are going to come from in the future. So this is the abstract, and I will actually let me scroll to the bottom here. I'll give you the bona fides of the various people who are involved with this, because I definitely want to do this here. So they have, where they come from here. We got a bunch of doctors from all over the places here. 1 second. The way they have this set up is a little awkward here. They designed the research. All right. Well, I'll have to find it in the other one. I'm having to do this on a phone. It doesn't like me. Let's put it that way. Abstract. Multisystem inflammatory syndrome in children, MIS-C, is associated with COVID, a coronavirus disease 2019, is a newly recognized condition in which children with recent SARS-2 infection present with a constellation of symptoms, including hypotension, multi-organ involvement, and elevated inflammatory markers. These symptoms and the associated laboratory values strongly resemble toxic shock syndrome, an escalation of the cytotoxic adaptive immune response triggered upon the binding of pathogenic superantigens to MHC2 molecules in T cell receptors. So just so you understand, that's what we've been calling the cytokine storm, that what's happening is when they say cytotoxic, they're saying killing cells, that the immune response is going so strongly it's killing cells. That's all that means. Here we use structure-based computational models to demonstrate that the SARS-2 spike protein exhibits a high affinity motif for binding TCR, interacting closely with the alpha and beta chains, variable domains, complementarily determining regions. That's saying that it can connect well to areas in the cells. The binding epitope on S harbors a sequence motif unique to SARS-2, not present in any other coronavirus, which is highly similar in both sequence and structure to bacterial superantigens. Why do I mention that? Because that's the part that only has a 40% resemblance. It's a strange 12-line insert into the code of this that's at the key of why the spike protein at the S1, S2 bonding site is able to do so much more. And it's the best, it's really, people consider it the smoking gun who want to look at this for why this is likely to be a biological weapon of some sort, or at least a biologically modified item. That's why we're going to talk about it today. All right. Further examination revealed this interaction between the virus and human T cells is strengthened in the context of a recently reported rare mutation, D839YNE, from a European strain of SARS-2. So we're going to have to keep an eye on that. There might be something really getting worse there. This is the first time I've heard of D839 being changed. Furthermore, the interfacial region includes selected residues from a motif shared between the SARS viruses from 2003 and 2019 pandemics, which has intracellular adhesion molecule-like character. These data suggest that SARS-2S may act as a superantigen to drive the development of MIS-C as well as cytokine storm in adult COVID-19 patients, with important implications for the development of therapeutic approaches. So it seems like the science is coming around to where we were a couple weeks ago, which is good. It means that we were following the preprints and the conclusions correctly, that we're seeing that some of these, that this is an immune response problem. And in fact, they're starting to study tocilizumab, which we talked about for quite a while, after hydroxychloroquine as something that potentially helps. It's a complex drug. But we'll go ahead and go forward here. So significance. Although children have been largely spared from severe COVID-19 disease, a rare hyperinflammatory syndrome has been described in Europe and the East Coast of the United States, termed multisystem inflammatory syndrome in children, MISC. And I think what this is related to Kawasaki because of how they're describing it. It seems very similar because they develop new terms for this all the time, and I'll keep an eye if this is either something that's analogous or the same. The symptoms and diagnostic lab values of MISC resemble those of toxic shock, typically caused by pathogenic superantigens stimulating excess activation of the adaptive immune system. We show that the SARS-2 spike has a sequence and structure motif highly similar to those of bacterial superantigens and may directly bind to the T cell receptors. The sequence motif not present in other coronaviruses. Keep in mind, not present in any other coronavirus, okay? Hint, hint, hint. May explain the unique potential for SARS-2 to cause both MISC and cytokine storm as observed in adult COVID-19 patients. So what are we seeing here? There is something in this virus that, we've seen it in other bacteria and we've seen it in other viruses. We've never seen it in this entire class of coronavirus. If you link every coronavirus out there that could be done, you would not find this trait. So where did it come from? Did it randomly mutate? Maybe. But when random mutations happen, just so you understand what mutations do, usually you see one base pair change. You'll see like a C become a G or an A become a T. Something will get flipped in there. But what we saw here in SARS-2, in COVID, was the insertion of 12 lines that were at a key element in the spike protein that has been used, by the way, as a common feature in genetic modification of viruses since going back to 1999, regularly done by research at the Wuhan Virology Lab, as well as at the University of North Carolina, and it was actually funded previously by the Departments of Health as well as the People's Liberation Army, of the People's Republic of China. The evidence of all you need to know is out there if you know how to read it, but they count on you to not understand what the small print says. That's what we look into. And we look into it because this is at the heart of how this is going to evolve. The weird insert they put in there, which adds the gain of function ability, is probably what's going to hint at what problems we should expect going forward. And that's why this is so interesting, this particular study, because we're going to look at what ends up happening with these respiratory and organ failures that we're seeing in people, including children, that are happening due to a misregulated immune response. Severe acute respiratory syndrome coronavirus 2, which causes COVID-19, is a coronavirus closely related to SARS and MERS coronaviruses. COVID can manifest in adults as severe interstitial pneumonia with hyperinflammation, while severe respiratory manifestations are rare in children. Recently, however, multi-system inflammatory system in children has been recognized in patients that either tested positive for COVID or had epidemiological links to COVID. After initial reports in the UK, many cases have now been reported in Europe and New York. However, no such cases have been reported in China, Japan, or South Korea, which have also been severely impacted by the COVID pandemic. And to me, that suggests that we're dealing with we're dealing with something that's related to the mutation, perhaps to the, what's the one they mentioned? I want to make sure I say the number right of it. That maybe this D839Y. And just so you understand, when all those things happen, 839 is the location of it, D was the previous amino acid, Y and E are the new amino acids that are replacing it, okay? So, and you can look up what all those mean. I mean, honestly, I couldn't tell you how to build it from the alphabet because these things are so complex. That would be like asking what purpose one letter has in light of a whole dictionary. It just doesn't work that way, but it's suffice it to say, where you see where all the problems link to one commonality, that's kind of how you do genomic research. Okay, where were we here? All right, MISC manifests as a persistent fever and hyperinflammation with multi-organ system involvement, including cardiac, gastrointestinal, renal, hematologic, dermatologic, and neurologic symptoms, which are highly reminiscent of toxic shock syndrome rather than Kawasaki disease due to marked demographic, clinical, and laboratory differences. So they're saying that they think this is this as opposed to that. The similarities to TSS and the association of MISC with COVID lead us to hypothesize that SARS-2 may possess superantigenic fragments that induce an inflammatory cascade and perhaps also contribute to the hyperinflammation and cytokine storm features observed in some severe adult COVID cases. The question we raised is, does SARS-2 possess superantigenic fragments that could elicit such reactions upon binding proteins in the host cell cytotoxic immune adaptive response? Such a reaction was not observed in the SARS pandemic of 2003. What is unique about SARS-2 and how recent mutations in SARS-2 S protein may have promoted such an increased virulence? TSS can be caused by two types of superantigens, or SAGs as they call it, bacterial or viral. Bacterial SAGs have been broadly studied. And just so you understand what I'm reading, superantigens is really read as SAGs, but I'm going to say SAGs because otherwise this could be hard to say. They include proteins secreted by Staphylococcus aureus and Streptococcus pyogenes that induce inflammatory cytokine gene induction and toxic shock. Typical examples are TSS toxin 1 and staphylococcal enterotoxins B and H. They are highly potent T cell activators that can bind to MHC class II molecules and or TCRs of both CD4 and CD8 T cells. The ability of SAGs to bypass the antigenic specificity of the TCRs results in broad activation of T cells and a cytokine storm leading to toxic shock. So what they're saying is that superantigens basically get around the usual way the immune system works and convince the killer cells to come out like crazy, which is why I gave you that article from Stat News before I read this so that you understood the theory. It's going around the interferons that kind of slow the response for the killer cells to arrive, and instead the interferons are just sitting there like dead walls in the water while all the fighters come on, and what happens is the fighting is so bad at different times that it in and of itself ends up being destructive because you have more violence happening than your body's ability to easily handle, and that's what the toxic shock is. that you're having a lot. Because you got to remember, when these viruses die, you have waste that has to be excreted. You have a lot of things going on in there. You have damage to the tissue, a lot of different things. And that's the microclotting, right? I mean, what better way is there to have blood out there than to start breaking things, you know? It's just like anything else. You want to have your house blow up, start cracking all the plumbing lines and the gas lines, and it won't be long before something terrible happens. In a lot of ways, that's not that dissimilar to what happens when you have a superantigen. Okay. Notably, superantigens do not bind the major antigenic peptide binding groove of MHC2, but instead bind other regions as well as the TCRs directly. More earlier studies showed that bacterial SAGs activate T cells by binding the beta chain of dimeric TCRs at their variable domain. More recent studies indicated they can bind either to alpha or beta chains or both. The question is then, does SARS-2 S protein possess any superantigenic fragments or domains that could bind to the TCRs, just so you understand. And the TCRs are the T cell receptors, right? So what we're saying is, just so I want to make you understand this thing here, that when we're talking about this is, if SARS-2 can bind directly to the T cell receptors, they can use them to basically hitch a ride. And that's what is potentially happening. So that would be not only that SARS-2 is causing the inflammation by the release of the T cells, but they are actually actively using them as well, and that's what this study is happening. Here we use computational modeling to determine whether SARS-2S possesses superantigenic activity. We demonstrate that an insert present in SARS-2, which is absent from SARS and MERS, mediates high-affinity non-specific binding to the TCR. Notably, a motif of 20 amino acids enclosing this insert unique to SARS-2 among beta coronaviruses has sequence and structure figures highly similar to those of the SEB toxin, and that's Staphylococcal enterotoxin. Furthermore, our analysis indicates that a SARS-2 mutation detected in the European strain may enhance TCR binding, suggesting such mutations may account for geographical differences in misoccurrence. These findings have important implications for the management and treatment of COVID-19. So what are they saying is that they're saying in this that COVID is bonding to your T cells, and that there is a strange insert that's allowing them to do it, that's causing them to have this ability to be immunodisruptive. So it goes here, and I'm just going to read, these are the results in discussion here, and we're going to skip all the results. Okay. In the interest of making this comprehensible for you, the listener, I'm going to go ahead and just read the top line subheadings of the results, and then we'll get to the discussion where it covers everything in a broader sense. But here's what they found in their research, and they have a whole bunch of really interesting graphics that show exactly how this works that are definitely worth checking out in this piece. SARS-2 spike harbors a high affinity for TCR, that's T cell receptor beta chain binding, which contains an insertion PRRA unique to SARS-2. So we have seen that, and PRRA is the insert here that is really important. In fact, I'm gonna go read just this part of it because I think it's important enough for the story we've been telling that I'm gonna read this part of the discussion, and then we'll skip over the other things because they get really, really technical. We first examined whether SARS-2S protein could bind to the alpha beta TCR. To this aim, we constructed a SARS-2 structural model based on the cryo-EM structure result for spike glycoprotein, and we used the X-ray structure of TCR resolved in a ternary complex with SEH and MHCI2. So they made models so you could see how these would connect. And they generated a series of structural models for possible SARS-2S glycoprotein TCR complex formation using ClusPro. Our simulations led to the binding pose presented in Figure 1A as one of the most probable mechanisms of complex formation, as described in detail in the supplemental information in Supplementary Figure S1. Therein, the TCR binds at the interface between the S1 and S2 subunits of the spike protein near the S1-S2 cleavage site. This close-up view of the interface between the spike and TCR domain reveals several strong interatomic interactions involving residues S680 to R683 on the spike, R70 to E74, and Q52 to D56 on the respective CDRs 3 and 2 on the beta TCR. We note that the TCR binding epitope on SARS-2 is centered around a sequence motif PRRA and its sequential and spatial neighbors. Comparison of SARS-2 to other beta coronavirus spike proteins showed that SARS-2 is distinguished by the existence of this 4-residue insertion. Remember, insertion. So what are we seeing? Something that isn't in there, where a whole chunk of code got added, preceding the furin cleavage site between the subunits S1 and S2 of each protemer. That's just saying that the protein spiked. Structural comparison of the trimeric S proteins between SARS and SARS-2 further shows their close structural similarity in general, except for the RBD, which is engaged in specific interfacial interactions, but the two spikes significantly differ near the PRRARS motif, unique to SARS-2, which is exposed to the extracellular medium. And what they basically show you, if you can look at it, is they show SARS-2 compared to every common bat virus, SARS virus, these pangolin viruses, and none of them have this insert. This insert is the key to the whole thing. Okay? So, further examination of the motif near PRRA reveals close structural similarity to the SEB superantigen, as well as sequence similarities to neurotoxins and the viral SAG. So, what they're saying in this, and I'm not going to read this because it would be hard to read, but what they're saying is that this looks like something you don't see in coronaviruses, but you see in superantigens, certain bacteria, and viruses. They say that it bears close similarity, I'm just grabbing this from there, close similarity to HIV-1 glycoprotein, okay? So this looks literally like someone took and chopped in a chimeric type feature, a function that really allows immune suppression. And we see that it is manifesting in that way and causing those damages. And as they say here, finally, because of the homologous superantigenic segment of SEB binding CD28, we tested the potential binding of SARS-2 spike E661 R685 onto CD28, considering the possibility that the target of the SARS-2 spike superantigenic segment might be CD28. Our simulations indicate the same segment can bind to CD28, further supporting the strong propensity of the fragment to stimulate T-cell activation. So they look at this, and I just use that as an example. That's another site we haven't talked about. CD28 might be another place in play. What seems like is this has an amazing ability to connect to existing different elements, both in cells and in the T cells, in the immune response itself. So the interferon's job, just so you understand, the interferon is a cell that goes in there that basically tries to lock the virus down so it can be removed. But we know that SARS-2 doesn't cause that. COVID wants to have the fighters out there because what can it do? It can weaponize those fighters. And the thing that's scary about this virus, if you're studying it, and for those who aren't understanding what I'm telling you it's getting better at weaponizing our own weapons against us. That literally it's learning how to go ahead and turn our immune system against us. And can we do things to stop it? Sure we can. But if you shut off your whole immune system as the answer, which is ultimately the problem with the treatments you would need, what risk are you going to run from other bugs, viruses, bacteria that's out there? And that's the catch-22. If the end game of SARS-2 is to make it where our immune system is untenable absent some external intervention, what kind of a control mechanism could you imagine that would be stronger than that in terms of modifying people's behaviors? And yet, this is a realistic possibility of where an endemic SARS-2 may end up taking us. So let's continue. SARS-2 spike retains other super antigenic or toxic fragments observed in the SARS-1 spike, including an ICAM-1-like motif engaged in stabilizing interactions with TCR-VA. And what does that mean? That means that they have fragments in the spike that allow for a more steady interaction with the T-cell receptor site. That's what that's saying, just so you understand that. And there's a lot of really in-depth pictures. And what you see, I'll try to describe it for you, is that there's several different ways in which these inserts really allow COVID to connect which is the heart of this. I mean, realistically, because if you're a virus and you can't find a way to connect on an atomic level with the different cells, you don't get to spread. And viruses, remember, don't reproduce on their own. They basically are parasitic, if you want to think of it that way. They have to get into the cell, and they have to take over the cell machinery and basically turn the cell into a copier for their code. So let's see here. A rare mutation, D839YE, recently observed in a SARS-2 strain from Europe, contributes to stabilizing the interaction with TCR. And it's interesting to mention this because if we're having this strain here go through, that's going to be very important. What means is that we might see more autoimmune elements come, which we didn't see so much at the beginning, and it's a change. So I'm going to read this part of the comments, and let's see what we get from it. Interestingly, the SARS-2 spike binding region harbors 3 residues that have recently reported to have mutated in new strains from Europe and the USA. D614G, which we've talked about a lot, A831V, which I know nothing about, and the new one, D839YNE, and that's just saying that it can go different ways. The former two may potentially interact with MHC2, while the latter, D839, is located potentially or close to TCR-VB and strongly interacts with N30. So what are they saying is that 614 is interacting with a different set, but D839 might be causing the T cell response to be off, and that might be what's causing the kids to get sick, that the T cells specifically. This is something that the existing antibodies in children, in younger people, is not proving as successful with. And as we see, as I reported in Brazil, and we see this rapid spread of all these different diseases, and strains, I should say, that you see younger people getting sick, it sort of makes me wonder if we're not seeing this become more commonly expressed. Now, and how severe it is, because we don't know that. Its substitution by glutamate in the D839E mutation increases the strength of the intermolecular and thereby virus T cell association. Even stronger interactions between the spike and TCR-RV are observed upon replacing D839 with a tyrosine, as illustrated in supplementary figure S4D. The interfacial interactions in this case are further stabilized by a hydrogen bond between Y839 and D32, an aromatic interaction between Y839 and N30, as well as possible electrostatic interactions with K73 and S97. Qualitative evaluation of the changing binding and affinity between the spike and TCR upon mutating D839 yields a gain of reductions in 2.2 kilocalories per mole, respectively. So what they're saying is that it takes a lot less energy to connect than it used to make it real simple. Thus, the D839YNE mutations would be expected to strengthen, support the above-described association between the super antigenic PRRA containing segment and the TCR-VB. So what are they saying? These mutations are making it where the PRRA can do more. And what do we observe? We're told this is a slow mutating virus. We've only been dealing with this 5 weeks, and I can already tell them 3, 4, 5, how many of these different things are happening. And your scientists are going out there saying, oh no, nothing's changing, nothing's getting different. I mean, the science is here for you to find. People who are lazy and who are just believing what they're being told by public officials are not telling you that. Here we go into the lab reports and we try to understand it. And when we're wrong, hey, explain to me what's happening here in a different way if you have a better way. And if you do, I'll listen to it. And if it's compelling, I'm more than happy to say that, I don't have it right. So let's see what else we got here. Just went back real fast. MHC2 is involved heavily with the CD4 cells we have. So that's part of the immune response. So we have a whole bunch of different pieces, and it's not really important that I get every specific one right. What it seems like almost is that COVID is learning to crack all the different elements of our immune system and learning how to weaponize it against us. And that really, really worries me, because if you wanted to spread something, the easiest way to do it is to make it where the host has no ability to offer resistance. And I remain incredibly worried about what the progression of this disease means. And I also remain worried beyond that for the potential for bioterrorism, where it would be very easy if you understand that a certain strain with a certain change would be more harmful. You could introduce it out there and you could find it, and I'm sure I am sure state actors are looking at doing this because of how rotten they're all being to their people and each other. I mean, and this is the world we live in, a world of bioterrorism. I mean, and whether it started, whether you believe COVID is real or artificial at this point is immaterial to that actual question. It's just too big of an opportunity to overlook. And you need to be aware of that. That is the risk going forward, especially as war doesn't look like it used to. I mean, why go ahead and fight a nasty battle when you can just go ahead and have your own, your enemy take care of themselves through a virus? And this is one of the reasons why we didn't do this. But in history, it's been done a lot, frankly, a lot of the advantages the Europeans had was by the fact they had survived the Black Plague and smallpox and the damage that did to African and Latin American populations when they landed. All right, so let's continue. There's a conclusion to the article, or it should say to the study we're reading, and it's been interesting, so let's go forward. An understanding of the immunopathology leading to severe manifestations of COVID in both adults and children is of critical importance for effective management and treatment of the disease. MISC shows remarkable similarity to pediatric toxic shock syndrome. Using in silico modeling and analysis, we found that SARS-2 encodes a superantigen motif near its S1, S2 cleavage site. This region is highly similar in structure to the SEB superantigen motif that interacts with both the TCR and CD28 and mediates TSS. SEB enables large-scale T-cell activation and proliferation, resulting in massive production of pro-inflammatory cytokines, including IFNY, TNFA, and IL-2 from T-cells, as well as IL-1 and TNFA from APCs. This cytokine storm leads to multi-organ tissue damage similar to what is now observed in MISC. We therefore propose that MISC observed in COVID patients may be mediated by superantigen activity of the SARS-2 S protein. To date, MISC is mostly observed in Europe and the east coast of North America and has not been described in Asia, despite sizable outbreaks of COVID-19. We show that a mutation at D839 found in a European strain of SARS-2 enhances the binding affinity of the superantigen motif to the TCR. This could at least partly explain the geographical skewing of MISC to areas where the European strain is endemic, and the identification of other strain-specific mutations may help predict where further outbreak of MISC may occur. Our findings raise the exciting possibility that immunomodulatory therapeutic options used for toxic shock syndrome may also be effective for MISC, including IVIG and steroids. Indeed, initial published and unpublished reports suggest that MISC patients respond well to IVIG with or without steroids. IVIG recognizes SEB epitopes and theirs may function by neutralization of a superantigen. Given structural similarities between SEB and the S protein SAG motif, there is potential for cross-reactivities of immunoglobulins, explaining in part the response of MISC cases to IVIG. So that's IV therapy. Other FDA-approved anti-inflammatory drugs tested in models of SEB, toxic shock syndrome, may also be effective, including CTLA-4-LG, which can inhibit CD28 co-stimulation, and the mTOR inhibitor rapamycin, which is already in use for COVID. In addition, humanized monoclonal anti-SEB antibodies have been described that could be of potential therapeutic use in MISC patients. Notably, it has been shown in the mouse model of TSS that the lethal SEB superantigen challenge can be prevented by short peptide mimetics of its superantigen motif. So they're saying different means of treatment where you can basically trick this into going ahead and connecting to the wrong thing. These are interferon and antibody type responses to bring back that part of the response that's being lost in this, because we have the killer cells, but we don't have the defender cells that buy the killer cells time to come to the right place and to lock them down. And of course, you got to remember that the killer cells have to be able to do what they can do, because now there's a complex interaction where we have seen from this very study that it appears that SARS-2 can sometimes take control over them as well, based upon the modeling that they've provided. It would be interesting to examine whether short peptide mimetics of the SARS-2 spike superantigen region might be employed to prevent or attenuate inflammatory cytokine gene induction and toxic shock in MISC patients. At present, the majority of antibody therapies under investigation are designed to target the SARS-2 receptor binding domains, and our simulations also indicate that RBD might potentially interact with TCRs. However, compared with RBDs, relatively fewer mutations are found in the SAG superantigen region of SARS-2. Notably, the PRRA insert is unique to SARS-2 and retained among all of its isolates sequenced to date. So they're saying that this is the part that doesn't change, that's key to it, and that literally is making it work. It might be constructive to design antibodies or drugs targeting this superantigen region to not only block the cleavage necessary to enabling viral entry. So remember, this is the mustard top, where this is the point at which it breaks, so then therefore it can ooze out, or if you want to think of a toothpaste top lid, a snap top lid, it oozes out the virus that way, and the more deeply it can invade, the more virus can come in at once. But anyways, to not only block the cleavage essential to enabling viral entry, but also modulate superantigen-induced inflammatory cytokine gene induction. Fortunately, severe respiratory manifestations of COVID in children as well as the development of MISC are rare. This may be due to trained immunity or cross-viral immunity to other coronavirus strains. T and B cells play an important role in the antiviral response. CD4 and CD8 T cells from convalescent COVID patients can recognize a range of SARS-2 epitopes, and the S protein represents a major target. Interestingly, T cells from unexposed individuals can also respond to S protein epitopes from SARS-2, which supports the hypothesis of cross-viral immunity from other coronavirus strains. So that's interesting. Then, in fact, previous coronaviruses do have a degree of immunity, which also suggests that treatments may be possible along that line. However, why only a fraction of infected children develop MISC is unclear. It is possible that a poor initial antibody response to the virus fails to neutralize superantigens, leading to immune enhancement following re-exposure, or that certain HLA types are more permissive of binding superantigens. And indeed, HLA has been shown to play a role in COVID susceptibility. Of 9 cases initially reported in the UK, 6 were of Afro-Caribbean descent, which also suggests a potential genetic component to susceptibility. It is interesting to note that approximately a third or fewer of MISC patients have tested positive for SARS-2, but that the majority all have serological evidence of infection or a history of exposure to COVID. This may suggest that SARS-2 superantigens caused a delayed hyperinflammation response in certain children. And this is something we're seeing over and over again. Keep this in mind, this long-term delayed response. This thing lingers, it kills interferons, right? And it comes back up. What is happening there? We don't know. And there's a lot of different pieces out there, a lot of speculation, but I still consider this to be a key question that really has so many ambiguities we don't know the answer. Superantigens have been implicated in autoimmunity by triggering self-reactive T cells. Antibody-mediated enhancement upon re-exposure to the virus may also contribute to uncontrolled infection and inflammation. It is also possible that despite a negative nasopharyngeal PCR test, the virus may still be present in the gastrointestinal tract. So let's keep this in mind here. When we are testing to see if this is done, we're doing the simple swab test, and what they're saying is it can still exist in your gastrointestinal tract. We saw an earlier study saying it could still exist in your lungs, and we've seen that this can be localized. So the idea that COVID's gone away because you tested positive or negative, I think that's wrong. I think it's surviving in other places, and we don't have the full amount of research yet, but I've seen at least in 3 different body systems from what we've reported that this thing continues onward, and it's still in there doing something, waiting for something. Maybe an opportunity, when you're in shock, maybe you get influenza and your body's overwhelmed, and then bam, this comes back up. We'll see what happens, but it's something to be very concerned about. And it's hard to predict, quite frankly. Okay, let's see where we are here. MISC patients demonstrate unusually severe gastrointestinal symptoms, abdominal pain, vomiting, and diarrhea, in addition to severe myocardial dysfunction and cardiac shock, and such severe GI symptoms are also frequently associated with the superantigen. In summary, we made 3 major observations. PRRAR and sequential neighbors interact with TCR, V beta residues D56, R70, and E74 at the CDRs, that's the binding domains. And this association closely resembles that of SEB-SAG with TCR-VB. So they're saying that this looks like another bacteria they've seen, the Streptococcus bacteria, that was literally being, that's an insert, right? Nearby D839 participates in this interaction, and its mutation to tyrosine would further strengthen the association with TCRV beta. And sequence motif N280 to T286, typical of ICAM1, further interacts with the TCRVA, further stabilizing and enhancing the association between the viral spike and host cell TCR. So keep in mind, so we know at least 3 things that can happen, that are starting to happen, that can make this more aggressive about being able to restrain the immune system. And I would predict with this virus, if we've seen something that can be done, we should be worried that it will be done, because I think that will happen. The first is the most important. The second is significant because it's the European strain. The third may be imparting a stronger host virus adhesion. Therefore, strategies used for the treatment of SEB-mediated toxic shock or approaches to block the interaction of S protein with the TCR may reduce hyperinflammatory manifestations of COVID in both adults and children. So you got to get in there somehow, try to block it. And that's what we're going to probably see be the emergent idea of this, that you want to have preventative treatments be put out there that would be able to accomplish some of these things that we have talked about. Okay, so I want to go here and do one other bit of piece of this. I think it's sort of interesting in here, and because we're doing pretty good, we're only an hour 14 in. So this piece is by, this was a preprint that was on May 21st, and it was on, where are we on? BioRxiv. It's titled, "A Previously Uncharacterized Gene in SARS-2 Illuminates the Functional Dynamics and Evolutionary Origins of the COVID-19 Pandemic." And I thought this was interesting because this piece specifically, it talked about the D614G change, but what it talks about is that there's other one that comes along with it, and they don't know what it does yet. So I want to read the abstract of this, and then maybe we'll go a little bit into the results. Understanding and preventing the emergence of novel viruses requires an accurate and comprehensive understanding of their genomes. And Chase Nelson is the lead author on this. He is, let's see what his bona fides is here. Give me 1 second. All right, so there's a lot of people here. We have people from the American Museum of Natural History, the Chair for Microbial Ecology in Munich, Department of Pathobiological Sciences in University of Wisconsin-Madison, University of Munich, Academica Sinica in Taipei, SUNY in Brooklyn, and Cal Berkeley. So there's a lot of people involved in this who work together on this one, let's put it that way. Okay, so understanding and preventing the emergence of novel viruses requires an accurate and comprehensive understanding of their genomes. One under-investigated class of functional genomic elements is overlapping genes, OLGs, which allow a single stretch of nucleotides to include 2 distinct proteins in different reading frames. Viral OLGs are common and have been associated with the origins of pandemics, but are still widely overlooked. We investigate de novo, that's new, OLG candidates in SARS-2 and identify a new gene here named ORF3C. And remember the last one has been talking about ORF3B, but ORF3C we might have actually a new gene in this. ORF3C has been documented elsewhere, but is unnamed, unannotated, or conflated with ORF3B or other SARS-related beta coronaviruses, or sarbecaviruses. In fact, ORF3C is not homologous to ORF3B, as the 2 genes occupy different genomic positions and reading frames. We find that ORF3C exhibits clear evidence of translation from ribosome profiling and important immunological properties. We then conduct an evolutionary analysis of ORF3C at 3 levels between species, between host, within host. Specifically, 21 representative sarbecavirus genomes show ORF3C is also present in some pangolin COVs, but not more closely related bat COVs. Just one more evidence that some sort of recombination was out there. This is not a bat sort of issue, but maybe it got grabbed. Who knows? Specifically, 3,978 SARS-2 genomes revealed ORF3C gained a new stop codon, G25563U, that rose drastically in frequency during the COVID-19 pandemic, and 401 deeply sequenced samples of SARS-2 demonstrate the recurrence of this mutation in multiple hosts. Surprisingly, the newly gained ORF3 stop codon hitchhiked early with haplotype and then they have a whole bunch of letters, but it ultimately equals out to spike D614G, which appears to drive the European pandemic spread. Are results like an ORF3 to other important viral accessory genes recombined, lost, split, or truncated before or during outbreaks, including ORF3B and ORF8 in sarbecoviruses? ORLGs deserve considerably more attention, as their rapid evolution may be more important than is currently appreciated in the emergence of zoonotic viruses. So I mentioned this, and I had a chance to take a little bit of peek in this. What's interesting about this and why I mention it is that the D614 apparently also is related and comes along with this ORF3 change function that allows this to be able to spread more aggressively for whatever reason. And that when you look at one place, you don't necessarily look at everything else with it. So I think it's definitely important to go ahead and take a look at this. And it's some really deep work that is, indicative of that there might be something important there that we can target that potentially could be a source for treatment. So I wanted to share that piece with you. That's just the abstract of it. We're not going to read any more than that because I don't think it would be helpful for you. And I did go through and read all these. So this was another piece I wanted to mention that I think is interesting to take a look at. It doesn't have any strong conclusions, but I think it's worth looking at. This is from May 20th. And Divij Matthew is listed as the first author. Deep immune profiling of COVID-19 reveals patient heterogeneity and distinct immunotypes with implications for therapeutic interventions. So once again, just going to read the abstract of this, and I'm letting you see what research is out there. A lot of it is about modeling, a lot of it's about other questions, but this one was interesting to me because it shows just how widely dysregulated the immune responses are, and that they don't know yet what's causing all of these. They're starting to figure it out, though, and I think it's at the heart of figuring out why the cases are severe or not severe. And this has a lot more detail as to what happened in different groups. And they were looking at individual manifestations, which I think for researchers or even for just lay listeners who want to go ahead and understand better why these are happening, it's a long study, but it is interesting, and it gives you a look of why and how different activations really cause certain problems. And what you find is that there's this recurring question of an immune response that is not concordant with what the body's experiencing behind the most severe cases. So here's the abstract. COVID has become a global pandemic. Immune dysregulation has been implicated, but immune responses remain poorly understood. We analyzed 71 COVID patients compared to recovered and healthy subjects using high-dimensional cytometry. Integrated analysis of 200 immune and over 30 clinical features revealed activation of T-cell and B-cell subsets, but only in some patients. A subgroup of patients had T-cell activation characteristic of acute viral infection, and plasmablasts could reach over 30% of circulating B-cells. However, another subgroup had lymphocyte activation comparable to uninfected subjects. Stable versus dynamic immunological signatures were identified and linked to trajectories of disease severity changes. These analyses identified 3 immunotypes associated with poor clinical trajectories versus improving health, and these immunotypes may have implication for therapeutics and vaccines. And why do I mention this? Is because literally there are different types of patients all within the COVID framework, depending upon what experience they have of COVID. Part of that, obviously, is going to be their inherent body conditions, comorbidities, and a lot of issues like that. However, another part of it is what mutations are you exposed to. And the fact that we're already having this degree of variety on a disease that really has only been infecting the West in a bad way, let's call it for 3 months at most, is really disturbing, especially for all those people who say, oh, no, this ain't going to change, no big deal. I mean, okay. Just the evidence is out there. It's just if you have the courage to keep listening and seeing it, or do you want to look away and say, hey, it's all right, we beat this, we're over it, yay, and it doesn't really work that way, unfortunately. I wish it did, but it doesn't. So we have to be honest about what's out there. All right, so we'll bring up the next one here. So let's see. This one, a lot of people have been asking, rising evidence of COVID-19 transmission potential to and between animals. Do we need to be concerned? This is by medRxiv. Andrei R. Akhmetsanov is the lead researcher, along with Natalie M. Linton and Hiroshi Nishishura. So let's read the abstract of this, and I'll let you know. Like I said, I'm just going to give you the examples of what they are and aren't afraid of, and this was heavily funded by the Japan Society for Promotion of Science. Severe acute respiratory syndrome coronavirus 2, the virus that causes COVID, has been detected in domestic dogs and cats, raising concerns of transmission from, to, or between these animals. There is currently no indication that feline or canine to human transmission can occur, although there is rising evidence of the reverse. We explore the extent of animal-related transmission. We aggregated 17 case reports on confirmed SARS-2 infections on animals as of May 15, 2020. All but 2 animals fully recovered and only had mild respiratory digestive symptoms. Using data from probable cat-to-cat transmission in Wuhan, we estimated the basic R0 under this scenario at 1.09. This value is much lower than the reported R0 for humans and close to 1, indicated that sustained transmission between cats is unlikely to occur. Our results support the view that pet owners and other persons with COVID in close contact with animals should be cautious of the way they interact with them. So what they're saying is at this point in time that it doesn't appear that they are super worried based on the evidence they have that cats or dogs specifically are going to have a big problem with this because it's such a low transmission number, but keep in mind that can change with a mutation, and then you could have cats or dogs become a viral carrier. Obviously, they're able to carry it. The question is, and they're mostly getting it from us, but it hasn't seemed to evolve yet in a way where we are likely to get it from them, and it doesn't have a severe outcome in them as much as us so far. We'll have to keep an eye on that going forward. That's an evolving situation, but right now, some good news for the cat and dog lovers out there, that it seems like they're okay. And if you get this, do be aware you might want to keep your kitty or your puppy away from you because you can actually get them sick much more easily than they can get you sick. So that is good news for the pet lovers out there. Okay. So this piece is pretty fascinating, but honestly, I couldn't get as much from it as I wanted to, and I really wanted to. And it might just be because I'm looking at this on the stupid Kindle, which, by the way, thank you again to all of you who are helping me get away from this thing and get back to being able to actually read a lab report on an actual computer. I will tell you, it's so much easier. Okay, so this piece is called Predicting Wildlife Hosts of Beta Coronaviruses for SARS-2 Sampling Prioritization. So what they did was they studied similar viruses or things that have similar attributes, and they were making some educated predictions, hypotheses, about what animals they thought would be most likely to be viral reservoirs for something like SARS-2. Here is the abstract. In this piece, the lead researcher on this is Daniel Becker here. Bring up the info and history so y'all know where they're from. Let's see where these people are. Indiana University, Georgetown University, University of Idaho, Université de Montréal. Let's see, Louisiana State University, University of Toronto. So they had a lot of people working together on this, suffice it to say. Okay, back to the abstract here. And it's a long paper, so it's definitely worth looking at, especially if you're into animal taxonomy. It would be nice if they would have used their normal names and I didn't have to look up every single one of them in Latin. Despite massive investment in research on reservoirs of emerging pathogens, it remains difficult to rapidly identify the wildlife origin of novel zoonotic viruses. Viral surveillance is costly but rarely optimized using Viral surveillance is costly but rarely optimized using model-guided prioritization strategies, and predictions from a single model may be highly uncertain. Here we generate an ensemble of 7 network and trait-based statistical models that predict mammal-virus associations, and we use model predictions to develop a set of priority recommendations for sampling potential bat reservoirs and intermediate hosts for SARS-2 and related beta coronavirus. We find that nearly 300 bat species globally could be undetected hosts of beta coronaviruses. Although over a dozen species of Asian horseshoe bats are known to harbor SARS-like viruses, we might find at least 2/3 of beta coronavirus reservoirs in this bat genus may still be undetected. Although identification of other probable mammal reservoirs is likely beyond existing predictive capacities, some of our findings are surprisingly plausible. For example, several civet and pangolin species were highlighted as high-priority species for viral sampling. Our results should not be overinterpreted as novel information for the plausibility or likelihood of SARS-2 or the ultimate origin, but rather these predictions could help guide sampling for novel, potentially zoonotic viruses immunological research to characterize key receptors like ACE2 and identify mechanisms of viral tolerance in experimental infections to quantify competence of suspected host species. So yeah, it's more interesting when you get into the paper. So what they said in the paper? They said basically that ferrets were something they were worried about, rodent-like things, and I thought it was weird. They went out of their way to talk about the minks and that was a possibility, and they thought deer might be. So we'll have to keep an eye on that that's out there. But these were them speculating based upon what we should look at. And what they're saying is people need to be asking these questions. We're not. We looked at the cats and the dogs. That doesn't look too bad. The ferrets, they're using them for testing regularly. So apparently that's a real risk. And you would figure if that is, and as we've seen from other diseases, mice, rats, things like that are animals we'll want to keep an eye on moving forward. So let's see what else I got here for you. I always try to have some good stuff for you. Okay. So this one I thought was pretty fascinating here, and I will end with this one for today. I'm not going to read all the details of it because it's just, I don't think you really needed to understand it, but this represents a different way of treating it. You know, we talk about vaccines and the problems with them, and we've looked at antibodies in those questions, but, you know, sometimes the best way is to fight fire with fire, and one of the ideas that is being put out there in this Chinese study is that bacteria can fight viruses perhaps more effectively. I mean, the body is chock full of symbiotic bacteria, and maybe that is a solution that is non-nanotech, that is non-vaccinated related, that might actually prove quite effective as a means of fighting this, because it turns out there are a number of bacteria that look like they might have some real opportunity to go ahead and be effective against similar viruses, and that need to be tested more with SARS-2. So this piece is by Shi Yu, and it looks like it's a Chinese piece. Li Ming Zhang, Ling Quan Tong, Nana Zhang, Han Wang. Okay, let's see where these people are all from. And these are from Tsinghua University, the Beijing Institute of State Microbiology, as well as, interestingly, a supporting researcher who's helping them here at the Department of Immunology at the University of Connecticut. So actually really good to see some cooperation between Chinese and American scientists happening there. I'm excited for that. All right, so abstract. Viruses are the major etiological agents of acute and chronic severe human diseases that place a tremendous burden on global public health and economy. However, for most viruses, effective prophylactics and therapeutics are lacking, in particular broad-spectrum antiviral agents. Herein, we secreted two bacterial lipases from a Chromobacterium bacterium named Chromobacterium antiviral effector 1 and CBA-E2 with a broad-spectrum virucidal activity against dengue virus, Zika, severe acute respiratory syndrome, coronavirus 2, SARS-2, human immunodeficiency virus, and herpes simplex virus. The CBAEs potently blocked viral infection in the extracellular milieu through their lipase activity. Mechanistic studies show that this lipase activity directly disrupted the viral envelope structure, thus inactivating infectivity. A mutation of CBAE and its lipase motif fully abrogated the virucidal ability, and furthermore, CBAE2 presented low toxicity in vivo and in vitro, highlighting its potential as a broad-spectrum antiviral drug. Hey, it's interesting to me. I like the idea of using fire to fight fire, and that you have a bacteria here in this CBAE2, and they go into a lot of depth about how it works in there, and you can see that and what the risks are for that. And it seems like the risks are manageable compared to what this does, because